Good afternoon and welcome to the, where are we? We're in the CMIP stage. So, my name is David Trescot. I am the CEO of a company called Hybrik. And what Hybrik does is cloud transcoding. So for the next 18 minutes, I'm going to walk you through what the cloud is and what cloud transcoding is and why do you do it. So the first thing is, you may not have heard about Hybrik, but you've definitely seen what we do. So if you've ever watched a music video with Vivo, or you've ever watched something on demand from Comcast, or if you've ever watched Sony television or something, that's actually, we do all of that transcoding. So we are a company, our customers include people like Sony, Deluxe, Technicolor, Vivo, et cetera. So we provide large scale cloud transcoding, and it goes beyond transcoding into media processing. So the first thing is, why does it matter? And the reality is that the video that people create and the video that people consume are different. That seems very obvious, right? But if you think about it, it actually means that every single piece of content has to be converted from what it was in to what it's being done. And the thing there is that the formats that are great for doing visual effects and editing turn out to be terrible for sending to people, because they're, so you have a big mismatch between the files that people create and the files that people that want to deliver. And that's where transcoding sits in the middle. So to start with, what I've got here is I have a few thousand queued jobs, and I only have like 10, 20 machines running. So the first thing I want to do is say, okay, I need more machines. So I'm going to go and say, look, in my machine configuration, let's give ourselves some more machines. Now, what the machine configuration does is basically just tell you a set of rules about when to launch machines. So, for example, this set is saying in the US East 1 region, launch spot type of C4X large machines, and instead of launching 10 of them, let's go ahead and launch 100 of them. And if I'm not using them, go ahead and get rid of them after 1 minute. And on the spot market, I can get them for 6 cents an hour. So what's interesting here is that my 100 machines, if I run them for an hour, cost me $6, right? So first off, I'm taking advantage of the cloud's cost effectiveness. Let's go ahead and enable some more machines here. So what this is doing now, we have all these queued jobs, and we're saying, hey, if you have queued jobs, go ahead and launch machines. So what it will do for me is begin to launch machines. So it goes out and finds machines cheaply. So you'll see what it's doing here is now there are all these machines showing up that are spot pending. What does that mean? Well, Amazon, AWS, Amazon Web Services, allows you to rent machines from them. Now there are two ways you can get them. You can pay the list price, which let's say the list price is $1 an hour. Or you can pay the spot price. And what the spot price says is that, well, if we're not using it, you can have it. And you can have it for 10 cents an hour instead of $1 an hour. So you get a big cost savings, but if somebody else comes along and pays 11 cents an hour, you might lose your machine. So what we do is we manage that spot market, so it doesn't matter if machines go away, we will redistribute that load. So our customers run thousands of machines, and the reality is machines go away all the time, and they don't care because we're constantly moving tasks around. So we take a job, a media processing job, is more than just transcoding. It might consist of quality assurance, analysis, transcode, encoding, delivery, and we then smear that over all the machines. So the customer doesn't care if machines come or go because we're constantly remapping them. So we'll take these, and as the machines come online, they go from spot pending to spot fulfilled to running, and then they begin to contribute to the transcode process. So what happens then is that the jobs themselves, so if we come over here on the jobs, so these are the jobs that are currently running for us, and this list increases. And if I look at a completed job is actually defined by, if we look at this job is defined by JSON. Now, what is JSON? I hear you cry. How many of you have actually ever heard of JSON? It's not bad. JSON, JavaScript object notation. Literally, all JSON is a really simple way of representing computer content in a human readable format. That's all it is. And it's just a very structured way of doing it. So if I ask you to write something out, and you to write something out, and you to write something out, the odds of you writing it out the same way are very low, right? You're all gonna pick a different way to write it. But with JSON, there is only one way to write it. If you want to write a string, you have to write it this way. If you want to write an object, you have to write it this way. So it's a very formalized way, and so it makes it great for computer-to-computer communication, because any computer can write it, any computer can read it. And so that's what we use as our language for defining this structure. So this, for example, this job has a source, which tells us where to go grab the file from, a transcode, which tells us what to transcode it into, a analyze, which says, hey, I want to analyze this file for certain parameters, right? I want to look and find out, does it have black borders? What's the blockiness? What's my data rate? All this stuff I can analyze it for. I want to run some QC on it because I want to make sure, for example, it's a music video, does it have music, right? That's a simple question, but believe it or not, before Vivo was using us, they didn't know. They would create thousands of music videos, and some of those music videos just didn't have the audio because somebody somewhere forgot to put it on. And the problem with all modern systems at scale is that no one can watch the content. Do you think anyone at Vivo is watching every single music video? And hey, every single music video gets encoded for Apple TVs and for iPhones and for Android phones and for Netflix. So all of these things, it's not just one file, it's being one file encoded for 40 or 50 different output locations. Nobody watches it. The only way you can actually test this stuff is through a scaled, automated QC process. It's the only way you can find out, did I leave in bars and tone? Did I leave in black? Did I have the wrong audio? Is it the wrong language? Does it have subtitles, etc.? So that's what the automated QC does. I then want to move the data to a new location, and I want to notify somebody if something is wrong, and I want to notify somebody if something goes right. So those things right there, if we were to take that job is actually also, you can represent that job as a, let's take something like this, as a, let's take a look at this as a job report. So I can take that job, and let's take a look at our machines for a second. So now as the machines spin up, now the spot is still spinning. That's interesting. So let's grab these machines and turn those on as well. So the machines, as the machines spin up, they begin to work on the problem that we've got. So in this case, we've got machines spinning up here, we've got machines spinning up there, and we'll take these, and we want to go ahead and grab these right here, switch those to on demand. We'll pick those machines up. So those jobs, as those jobs begin to run, what I can do is I can say, okay, what is happening here to those systems? And I can see all the ones that are currently running, all the transcoding that's currently happening in the system, and find out, okay, what am I currently working on? I can also analyze that content. So one of the things we're looking at is that I've got content, how do I find out about the content, right? What do I know about that content? So if we take something like this, I can say, all right, this content, for example, let's take a look at Vivo, because we have some of the Vivo source. I can say, all right, this particular Vivo source, what do I know about that Vivo source? What can I find out about it in terms of how big it is, what data rate is running, what size it is, etc. I can also do deeper analysis where I want to go in and I want to say, all right, this particular data, like here's an example, here's the original video for Vivo, here's a 1 megabit version, a 2 megabit version, and a 3 megabit version. Which of these is good enough to put on the website? Well, we can actually do what's called a VMAF analysis, and we can actually find out whether something is good enough to be on the website and say, yep, it turns out that the 3 megabit, if we look at the analysis on that 3 megabit, it's actually good enough to put on the website, and we can actually see what the result of that is. Again, you can do that in an automated fashion. This becomes really important. Again, why? Because I can't afford to have somebody standing there testing every individual file, trying to say, well, is this good enough? Is this good enough? Is this good enough? Well, does this look okay? So you can automate this process. You can use tools like PSNR, SSIM, Netflix VMAF, for example. The same technology that Netflix uses to optimize their output, we've got in here, so we can optimize the output. And it becomes important, if you're Vivo, This video was originally encoded at 4.5 megabit, but we were able to show them that, hey, you could encode it at 3 megabit and still get the same visual quality. And, well, seems like, do you care? 4.5 megabit, 3 megabit? Well, if 25 million people are going to watch that video, yes, you care. Because you're paying, as the content deliverer, you pay for every piece of that content that gets sent is something you're paying for. So optimizing that becomes very important. And optimizing it automatically becomes very important because you can't justify, again, having a person working on that. We work with customers who have 20 and 30,000 library files, or someone like Vivo who might be dealing with 500,000 music videos. They can't afford to go optimize this by hand. So I can take a look at something else. So if we take let's take another job here. Let's add in something like this. So what I'm going to do is I've just queued up a job. So this queued up job is going to go, the first thing I'm going to do is say, hey, are there any machines available to work on that job? If there are, it moves from the queued state to the active state. So in the active state, let's see if it's gone active yet. Hasn't gone active yet. So what happens is when a job moves into the active state, it begins to work on that transcode. So that's roughly a 2-minute process to begin to happen. So then what happens is that we go from the media analyzer, all of this is broken down into tasks. So our view of things is that there are tasks. Every job, right? Every job has a series of tasks. Analyze, copy, DPP packaging, etc. And what these tasks do is the different types of tasks can be allocated to different machines, and then we can track what's going on with those different machines. So we can find out, okay, what's the performance of this file? What was the encoding performance? How many frames per second did it go? What bit rate did we get to, etc. So what happens there is that in the system, we can sit there and track every different type of file, and we can find out all the parameters of that file, including things like, okay, what is the blockiness of this video? Why would blockiness matter? Well, if you have an encoding error, how does that encoding error show up? It shows up as little blocks. Well, if you can automatically detect the blocks, you can find and fix errors without having your customers report them to you. Things like the audio settings, the video settings, where everything is, the blockiness of something, the levels of a file, the broadcast safe, etc. All this data gets handed back. And our customers largely run this, some of them use this, but mostly it's being done through the API. So they're actually using a programmatic way to control what they're doing with us. So let me I'm going to fire up one more set of machines here just to show one more thing. Let's grab I'll do a QC play here. So let's grab this guy and go ahead and we'll set some machines here for this. And launch these. And now our current jobs right now, if we take a look at our current job list, we're at something like, okay, so now we're running 100 machines now for the 100 jobs that we have. So we've also got, in this case, I want to close this video wall, and let's go ahead and grab see if our segmented one came through. Did I submit it? It'd help if I submitted it. And while that one's been submitted, it goes to queued. From queued, it will go to, so there's our segmented job there. It's going to queue up and go in. And then I want to show you one more thing in the storage browser. We're going to go over here, and keep in mind, we're using storage right now on S3, but we can actually support things like SwiftStack, which can control storage that's local. So we can actually use local content and transcode it in the cloud, or something like Wasabi, which is a S3 alternative. So those are both supported. So let's take something like this file. And let's go ahead and play this file. Now, this is a little bit tricky because this file, if we look at the media info on this particular file, okay, it's a QuickTime file. That sounds okay. What's the bandwidth of that file? How many people here think they can go into their browser and play a 1.1 gigabit file? Forgetting about the fact that it's ProRes, and there is no way, ProRes doesn't make a decoder that runs in a browser. So even if this was a 50 megabit file, you couldn't play it in your browser. So you have two problems. One, the file is in the wrong format. Can't play it in your browser because of that. Second, the file is enormous. So what do you do? This is one of the downsides. If you were on your local machine, when you want to play a file, what do? You double click on the file and it plays, right? That's easy when it's local. What about when it's on AWS? What do? What people do nowadays is they download it, right? That's the only way they have of playing that file, is to literally take that 400 gigabyte file, download it, and then play it. And that gets very difficult when you're dealing with things like, for example, here's a file. Is it in French or English? Well, if the name, oftentimes you remember these names of these files are like lpkzz523.mov. I have no idea whether it's in French or English. Maybe it says it's in French, but it's actually in English because somebody mislabeled it. How do you find out? So what we've done is something we think is kind of interesting, which is a online player. And what the online player does is it actually does live transcoding of the content in the cloud. So you take the live, so what this does is take the machines in the cloud and say, all right, let's use those machines in the cloud and make those begin to transcode the file live. So it transcodes the file and allows us to play that file live. So let me change this to a, just because we'll save that off. And what this does then, if we set these running here, so this guy is actually running that 1 gigabit file, is playing this live. Now, is it really playing the 1 gigabyte file? Is that what I'm seeing on my screen? Is it the 1 gigabit file? Well, no, it's a live transcode of the 1 gigabit file. So this, because I'm playing it off my phone, off my internet connection off my phone, is really down to like a 3 megabit file. But what this allows me to do, which is really quite handy, is I can go through and I can start looking at things like, hey, let's set a mark-in point. So right off the bat, here's a common scenario. Your master file is sitting in the cloud, but the master file has a bars and tone at the front, right? And we need to trim that off before we trigger the job. Normally, what people have to do is they have to download the file, put it in an editor, trim it, save the file back out, load it back up to the cloud. Well, we can do those basic editing operations directly in the cloud without having to bring the file local. And so you can also do things like change the audio mapping, change things, decide what you want to composite on top of it, etc. And then trigger a job. You can then trigger a JSON file that you wanted to use, like we wanted to use this one, and it'll replace the source with this file with these trimmed in and out points, or cropping, etc. So it becomes a way of dealing with the cloud as if it were local content. So we think that's a really important process there. And if we took that as well, so let's take a look at this one. Let's take a look at active jobs here for a second. So we've got this temporal split running. Remember, I actually have two temporal splits running. What I'm going to do here is, let's take a look at let's search for just that temporal split, and we're going to show the different tasks. So this is the movie Rock of Ages, right? Now this movie Rock of Ages is a 2-hour movie, and let's say I'm trying to get that 2-hour movie done faster. What I can do is I can say, well, let's take this. This guy is broken up, and it's actually running. The movie is being rendered on different machines. So I'm rendering this movie on different machines. Sorry, I accidentally launched 2 of these jobs, so half of them are running on one and half of them are running on the other. So this one, if you can see, has 41 different encodes running here. I'll just get this one out of the way. And this guy will turn off the background player so you can actually, sorry, I'm running on a limited internet connection here, so I'm doing my best. And what I want to do is take this guy, and let's just look for that segmented job, and we'll go for large. And that's the movie being encoded. But if we look at it, it's actually, we've taken that and smeared that out over the available machines. 3, 2, 1, and it's supposed to show up. 3, 2, damn it. Okay, so imagine, if you will, that you're seeing all the little pieces of the movie show up at one time. I'll just go back to this. The movie's completed. There's a problem with doing a demo when you don't have enough time. It actually goes faster. That movie, it took the 2-hour movie and broke it into all these 3-minute chunks and assigned all the 3-minute chunks to a different machine. So if we took this guy and let's go ahead and delete him for a second, and I'm going to restart him. So you can see. So that becomes very important because right now a lot of things are moving to 4K and to H.265, right, encodings. Well, one of the things you have to realize is that if you have, when you go from a standard, like an HD, a 1080p, up to a 4K, you actually quadruple the number of pixels you're dealing with. And when you go from H.264 to H.265, you're actually making a jump of about a factor of 10 on the, so this is now the movie. And let's just limit ourselves to the movie itself. So you've now got a factor of 10 in terms of processing time. So that means you've actually got a factor of 40 in terms of how much processing time it's going to take you to do things like UHD, H.265, Dolby Vision. All of these things are huge processing things. So this is the feature film. So if you are ADD, this is awesome because you can watch the entire 2-hour movie in 5 minutes. And it's very it's very time efficient. So this is the entire movie going through. Here are the end credits and stuff. So you can just kind of get the whole gestalt of the movie in one showing. And what this is doing is these machines, right? So I'm running this on 40 machines at 10 cents an hour per machine. So any mathematicians out there? 40 machines, 10 cents an hour is $4. Yeah, but here's the thing, it's $4 an hour. How much are we using? 5 minutes. What's $4 divided by 12? We'll go with 28 cents. So the feature film being encoded here, I'm doing for 28 cents of processing time, right? There are companies that will charge you $100 to do this. So it's a very different model of how to approach things when you have essentially unlimited processing power in the cloud. How am I doing on time back there? She's giving me the sim. I don't know, she's flipping me off in the back. So I have a few minutes more. So what's important about this is everything we do is a flat fee. So we don't charge per gigabyte, per minute, per hour, anything. We just charge a flat fee. So to give you an idea of that, here's a price comparison done by Jan Ozer. And if you can see that, I hate to badmouth the competition, but this is the competition, and they kind of suck because this is where we are. Now this is our cost plus the Amazon cost. Now the thing that's unique about us, compared to anyone else out there, is that in our system, the processing happens in your Amazon account. It happens on your AWS storage and on your AWS processing. But all the software that manages it and all the software that runs is ours. So you don't have to worry about AMIs and machine instances and cloud spot. It's all managed by us for a flat fee. No transcoding cost. No cost for any per file, per minute, per gigabyte. It makes us generally 20 times less expensive. So there's a reason why we are the leading provider for the largest service businesses in the world, right? So the Sony D80Cs, the Deluxe, the Technicolors, those companies live on that margin between what it costs them to do something and what they're charging the customer. So we are their profit margin because and our view of it is that, you know, a lot of companies have actually built their own systems. Like they go into FFmpeg and they kind of build their own systems, and those companies have now started coming to us because it's, you know, we can go to them and say, look, for less than the cost of one engineer, you can have a complete system. And this system, I'll tell you a funny story, the folks at Netflix came over today and they were like, this is what we have internally, that we have 60 engineers who built. Only you guys have a better UI than we do. because of course their UI was built as an internal tool to just deal with their stuff. So what we do is we give you all the tools you would have if you were Netflix, but we give it to you at a very cost-effective price. So at our system goes, we have only 3 prices: 10 machines, 100 machines, 1,000 machines. 10 machines is $1,000 a month. 100 machines is $5,000 a month. 1,000 machines is $10,000 a month, and that is all you can eat. That's anything you want to pump through that, right? So, and of any machine type. So literally, we run the largest transcoding farms in the world for the largest media companies in the world, and so that's our shtick. So with that, I think it's a little bit hard to do questions up here. So what we're going to do is that if you have any questions, I'll be back here behind this, so they can get ready to set up the next one, or at SSU 9906, which is, I don't know, a good 100 feet that way. So if you just go down the aisle, we're there, and you can get a sort of personal demo and talk about that. So that's it. I'm out. Thank you very much for your time. Cheers.